Did you know that you can undo any knot using the fourth dimension? Let's be clear on what we mean by a knot. A knot is a single closed piece of string that is allowed to move around in space, but not allowed to intersect itself. Before we go into how to undo a knot, we need a way to tell if a knot is already undone. Here's one way to tell. Travel along the knot. If the points that are reached first are always under the ones that are reached later, then the knot is undone. That is, it can be deformed into a circle. This is true for all knots. We'll call undone knots trivial knots. In order to make any knot into a trivial one, all we need is a way to invert crossings without the string intersecting itself. This might not be possible in 3 dimensions, but with 4, it's always possible. Trying to visualize the 4th dimension is not an easy task, so we need a clear way to represent it. Start with 2 points. When you connect them together, you get a segment. When you take 2 segments and connect them together, you can make a square. Take 2 squares and connect them to make a cube. If you connect 2 cubes, you can make what is called a tesseract, the 4th dimensional analog of the cube. We're going to use the tesseract as a guide for our manipulations in the 4th dimension. A point in 3D space can move left, right, up, down, forwards, and backwards. When we add the 4th dimension, it can move in a new direction. We'll call this direction ping and pong, but really we can call it anything we'd like. If we wanted to be exact, we could represent each point in this 4D space with coordinates. Take any knot and zoom into a crossing. We'll color the 2 parts red and blue. For the moment, the red string is above the blue one. Our goal is to swap them without making the strings intersect in the process. This is where the 4th dimension comes into play. We will use the tesseract as a reference for our maneuvers. Start by stretching the red string along the pong direction like so. Then move the blue string up. Now move the red string down and back along the ping direction. We have succeeded in inverting the 2 strings. Those with a keen eye might have noticed that the strings appear to have intersected at this step. But in fact, this intersection is only an illusion caused by the projection of a 4D object onto your 2D screen. To check this, notice that this point lies on an edge that only travels in the 4th dimension, so we can tell that the point has a non-zero ping-pong coordinate. Whereas all the blue points in this frame have ping-pong coordinate equal to 0. Therefore, the 2 points cannot be the same. This is a benefit of using the tesseract as a reference. We can be sure of the coordinates of all the points on it. Now you know the 2 steps to undo any knot using the 4th dimension. First, travel along the knot to figure out which crossings to invert. Then, use the tesseract method mentioned before to invert them. And you've undone the knot.